Hey math kids, today we're going to talk about planes in the context of vector math and a definition of being parallel. A vector is parallel to a plane if by traveling along the vector we remain on the plane. So if we have a plane that looks like this, we have a vector that stays on the plane, then we say that's parallel. Okay, now vector equation of a plane is going to look like this. Okay, so R is the position vector. A is the position vector of a known point on the plane. So this is a known point. This is the position vector of like any point on the plane. V and W are two non-parallel vectors. Okay, and then S and T are real numbers. Okay, and then if we're talking about a normal plane, a vector is normal to a plane if it is perpendicular to all vectors which are parallel to the plane. So if we have a parallel vector, this has to be 90 degrees with that. And also if we had one like that, it would have to also be 90 degrees to that to be normal. Okay, normal equation of a plane is R dot N, which equals A dot N. Okay. And so once again, R is a position vector for any point on the plane. A, once again, same thing, is a known point. And then N is perpendicular to those. And yeah. Okay. A few more things before we do an example. If a plane has a normal vector n and it passes through the point x, y, z, then it has an equation ax plus by plus cz, which equals a big X plus b big Y plus c big Z, and that's equal to d, and d is a constant. Okay, this is the Cartesian equation of a plane. Alright, that was a lot of information just to throw at you, so let's kind of use it in these examples and see if that makes more sense. Find the equation of the plane with normal vector. So we're going to call this one n, which passes through the point -1, 2, 4. Okay. So we're just going to use that last problem where if this is A, B, C, and this is X, Y, Z, then we get AX plus BY plus CZ equals A big X plus B big Y plus C big Z is equal to D. Okay. So we just plug these in. We get 1 times X plus 2 times Y plus 3 times Z. And then we do this times this. 1, -1, 2, 2, 3, 4. And so we get x plus 2y plus 3z. Let's see, that's negative 1, that's 4, that's 12, 12, 13, 14, 15, 16, minus 1 is 15. So that would be our Cartesian equation, of the plane. Okay, next one. Find an equation of the plane that goes through A, B, and C. We want to find it in vector form and in Cartesian form. Okay, so to do this, we're going to we need to find two non-parallel vectors. So we're going to look at AB, and we're also going to look at CB. So B is 3, 1, 1. A is negative 1, 2, 0. So that's a plus sign, so that's 4, negative 1, 1. And 3, 1, 1, minus, minus, minus. And 1, 0, 3. 2, 1, negative 2. All right. So if we wanted to see if these are parallel, I would look at the middle, and we'd have to multiply this by negative 1 to turn it into this. But if I multiply 4 by negative 1, it doesn't become 2. So we know that those are non-parallel. And then we're going to go back to that vector equation of a plane, which was position vector equals known point vector s times, I forgot the letters, but maybe it was v and w, something like that. Okay, so we're going to use this. So our position vector is just x, y, z. So that's our r. We have a known point vector, so I'm just going to use c. And then we're going to use the two vectors that we just created up here for the other two. So 4, negative 1, 1. And then 2, 1, negative 2. Okay, once again, s and t are real numbers. And this is our vector equation for that plane. All right, now we need to find for the Cartesian, we need to find a normal vector. And so to do that, we have to do a cross product. So to find n, we're going to take AB, which we already know, and we're going to do cross AC. Whoops. We still need those for a second. So we need 4, negative 1, 1, cross 2, 1, negative 2. Now I can move down here. Okay, so I, J, K. All right, 4, 1, 2, 3, 4, negative 1, 2, negative 2. Okay, so we're going to go this way first. negative 3 minus negative 2. That's our I minus j plus k. 12 minus 2, negative 8 minus negative 2. Alright, that's going to be a plus sign. Overall, that's negative 1 I. And then here we're going to get minus, overall this is 10 j. Add those together, we get negative 6k. So we can use this vector, or if we want to take out, because this vector would be negative 1, negative 10, negative 6, written in component form. And because if this is n, we could also have this, which means we could just use this piece of it, because these would be parallel to each other, and if they're parallel to each other and this one's normal to the plane, this is also normal to the plane. So to make it easier, we're just going to do kind of the positive version of all those, but we could leave them negative as well. Now that we have the normal, we have our n, we can use ax plus by plus cz is equal to I forgot the letters off the top of my head. A big X plus b big Y plus c big Z is equal to d. Alright, so we're going to use just a point that we haven't used yet, so let's use a. So negative 1, 2, 0. Okay, just rewriting that and using that. So this is our A, B, C. This is our big X, big Y, big Z. So we do negative 1 times negative 1. It's going to give us a 1. Negative 10 times 2 is negative 20. Negative 6 times 0. Oh wait, I did the right side. I'm sorry. Okay. So this is going to be negative x, negative 10 y, negative 6 z is equal to negative 1 times negative 1, which is 1, negative 10 times 2, which is negative 20, negative 6 times 0, which is 0. And so we get negative x minus 10y minus 6z. I used the negative ones even though I said I wasn't going to. That's okay. And then negative 19. Now if we want to divide everything by a negative, we can, just to make it look a little bit nicer. That's what I was trying to avoid in the beginning, but it's okay. Alright, so that is our equation in Cartesian form. Okay, so let's find the parametric equations of the line through a equals negative 1, 2, 3, and b 2, 0, negative 3. Hence, find where this line meets the plane with equation x minus 2y plus 3z equals 26. Okay, so first we'll find the vector AB, which 2, 0, negative 3, minus, 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 negative 1, 2, 3. That's a plus sign, so that's 3, negative 2, negative 6. And then if we put this into vector form, so if we go x, y, z, and I'm going to use point A, so negative 1, 2, 3, and then this would be our direction vector. Now we can write parametric equations. We can say x equals negative 1 plus 3t. We can say y is equal to 2 minus 2t, and z is equal to 3 minus 6t. And if we just plug in those values up here, we can see where they meet each other. So we do negative 1 plus 3t. So I plugged in for x right there. And then minus 2 times y, 2 minus 2t, plus 3 times 3 minus 6t is equal to 26. Okay, so all we need to do now is simplify this. Distribute 9 minus 18t, distribute negative 4 plus 4t, negative 1 plus 3t. Okay, let's see, circle the t's. So if we have negative 18 plus 4, that's negative 14, and then negative 11, and then we have negative 5 and 9, so that's 4. Okay. And then we need to find like our x, y, and z values. So we know that when t equals negative 2, that's when they're going to meet. And so we're going to plug in t equals negative 2 to these. So x equals negative 1 plus 3 times negative 2. And we get negative 1 minus 6. So x is equal to negative 7. Now we're going to plug in negative 2 to the y. Okay, and then the z. Okay, and we just need to write that point, negative 7, 6, 15, and that's where the line meets the plane with that equation. All right, I think we just have one more. Yeah, just one more. Okay, suppose n is the foot of a normal. So n foot normal from A to negative 1, 3 to the plane. Find the coordinates of n. And hence find the shortest distance from A to the plane. Okay. So we have foot of a normal goes to A. We also have that. This is 90 degrees. Okay, and so we also know that our normal is just coming out like that. Okay. So to find our normal vector from this, we just pull out our A, B, and C. So it's 1, -1, 2. Okay. And if we set that up, x, y, z is equal to our point, which is 2, -1, 3, plus t times our normal vector right there. We can pull out parametric equations. Okay, and t is a real number. Okay. Now we want to know where this meets the plane, so we're going to do what we did on the last problem and just plug in these purple values into these white values. So 2 plus t minus -1 minus t plus 2 times 3 plus 2t is equal to 27. Okay, we just need to simplify this now. 2 plus t, distribute the negative, plus 1 plus t, distribute the 2, plus 6 plus 4t equals 27. Combine our t's, so 4, 5, 6t, 2, 1, 6, 6, 7, 8, 9. Subtract 9, 6t equals 18, which means t is equal to 3. Now, if we want to know the actual coordinates, we're going to plug this into these. So x is equal to 3 plus 3, or 2 plus 3, oops, 2 plus 3, so x is equal to 5. Y is equal to -1 minus 3, so y is -4. And z is equal to 3 plus 2 times 3, so that's 6, so that's going to be 9. And so the coordinate is 5, -4, 9. Okay. Now, to find the shortest distance, we just need to find the magnitude of AN. So if we come back up here, we just need to find the magnitude of this. Alright, so first I'm going to find AN. And by the way, this is N. Okay, so A is, whoops, we do N first. So 5, -4, 9, minus, minus, minus. And then A was 2, -1, 3. 2, -1, 3. So that's 3. That's a plus sign, -3, and that's 6. Now we just need to find the magnitude of this. 3 squared plus -3 squared plus 6 squared. So that's 9 plus 9 plus 36. That's 18 plus 36. 40, 54. And all these were under square roots. And so the shortest distance is the square root of 54 units. If you need additional help, please come to Math Lab. Until then, calculate it.